For what the value of x to the power series converges, the series as n go from 1 to infinity of negative 1 to the power n minus 1 of x to the n over n. This is an alternating series, and in this case, it is an alternating power series. The first term, when n equals 1, is positive. X to the 1 over 1 is x. The second term is negative, x squared over 2. The third term is positive, x cubed over 3, and so on. To determine the values of x such that this power series converges, we first need to use the ratio test. The setup for the ratio test is the limits as n go to infinity of a sub n plus 1 over a sub n. We generally take the absolute value of this ratio. So we can just simply ignore the factor negative 1 to the n minus 1 or negative 1 to the n. In this case, the general term a sub n is negative 1 to the n minus 1 x to the n over n. And therefore a sub n plus 1 is negative 1 raised to the power n plus 1 minus 1, because we simply replace n with n plus 1. X to the power n plus 1, and again replace n with n plus 1. The denominator is n plus 1. We only need to evaluate the limits of the absolute value of the ratio, so we won't need the factor negative 1 to the n or negative 1 to the n minus 1. This is now the limits as n go to infinity of x to the n plus 1 over n plus 1 times the reciprocal of a sub n, which is n over x to the n, with the absolute value. Again, the absolute value of the negative 1 factor is positive 1. We will still need to write the absolute value in this case because of the variable x. Divided by a sub n is the same as multiplying its reciprocal. Before we take the limit, we need to simplify this expression. The numerator is x to the n times x times n. The denominator is n plus 1 times x to the n, so that we can cancel x to the n out. After we cancel out x to the n, we have the limits as n go to infinity of the absolute value of xn over n plus 1. But this limits only depend on n, so we would factor out the absolute value of x. Inside the limits is now n over n plus 1. And we know that at n go from 1 to infinity, there is no need to put the absolute value around n. But we do need to put the absolute value around x. As n go to infinity, n over n plus 1 go to 1. So this limit is the absolute value of x. The ratio test states that this limit needs to be less than 1 for the series to converge. In this case, the value of x that we need for this power to converge is any x that is between negative 1 and 1. It is strictly between negative 1 and 1. We're still not done yet. The ratio test says that if the limit is less than 1, then the series converges. So we know that for all of the x between negative 1 and 1, strictly, the series will converge. But what about the endpoint? If the limit of the ratio a sub n plus 1 over a sub n is 1, then the ratio test says that the test is inconclusive. In this case, the limit is 1 when x equals negative 1 and x equals 1. So we still need to check the endpoint because the test says that it is inconclusive. With inconclusive tests, we would need to use some other method. In this case, we simply plugged in the endpoints. When x equals negative 1, we obtain the series n go from 1 to infinity negative 1 to the n minus 1, and we replace x with negative 1 to the n power over n. We take the given series and we simply plug in negative 1 where x is. Simplifying this, we have the series as n go from 1 to infinity, negative 1 to the n over negative 1. This is what negative 1 raised to the power n minus 1 is. Negative 1 to the n in the numerator, and in the denominator. The numerator is negative 1 to the n plus n, which is 2n, over negative n. But if we take negative 1 raised to an even number, then it is positive 1. So the numerator is positive 1 and the denominator is negative n. And this is the series n go from 1 to infinity, negative 1 over n. We know that this is the negative of the harmonic series 1 over n. So this is the negative of the divergent series. It is therefore divergent. So we can't use the endpoint negative 1. We still need to plug in x equals 1 and check the right endpoint. When x equals 1, the given series is n go from 1 to infinity of negative 1 to the n minus 1. We replace x with 1 to the n power over n. And this series is n equals 1 to infinity of negative 1 to the n minus 1 over n. And this is an alternating harmonic series. The harmonic series itself is divergent. The negative of a harmonic series is also divergent, but the alternating harmonic series is convergent. And so, since when x equals 1, the series converges, we would use the right endpoint. And so this series converges on the interval open negative 1, close 1, or negative 1 less than x less than or equals to 1.